Alright, so this video will show you how to use bond energy in order to calculate the enthalpy change of reaction. So here's a refresher of some things you'll need to know in order to do these problems. So the change in enthalpy, or delta H, is the heat given off or absorbed by the system or reaction. Another thing you'll need to know is that bond energy is the amount of energy required to break apart a bond. And in order to calculate bond energy, you have to know how to do Lewis dot structures. And you'll need a chart like this one that tells you the bond energies and the bond type. So the form of a reaction is reactants going to products. And reactants are bonds being broken. And this is endothermic because it takes energy to break bonds. Whereas products are bonds being formed. And this is exothermic because it releases energy to form bonds. The reason it releases energy is because when atoms are joined and make a bond, they go to a more stable, lower energy state, which then releases that energy. Since enthalpy is heat given off or absorbed, we want to determine if the reaction is endothermic or exothermic, if it's absorbing heat or if it's giving off heat. And in order to do this, we take however much energy is absorbed, so that's the bond energy of the reactants, and subtract however much energy is released. So that is the bond energy of the products. So we know that the bond energy of reactants minus the bond energy of products is enthalpy, or delta H. So now let's do an example. This question is asking to calculate the enthalpy change for the following reaction. The reaction is 2H2 plus O2 gives 2H2O. So the first thing we're going to do is find the Lewis dot structures of each of these. So H2 is going to be like this, but since there's two H2s, we're going to draw two of these. O2 is going to look like this, and H2O is like this, but again, since there's two H2Os, we repeat it twice. So once we have the Lewis dot structures drawn out, we look at a chart to determine the bond energy of each bond. So for 2H2, the bond of an H to an H is 432 kilojoules. But since there's two, multiply that by 2. And then we're going to add O2. So this is a double bond of O's, which is 433 kilojoules. Now, for 2H2, we have an H and an O bond, which is 464 times 2, since there are two of them. And we're going to multiply that by 2 again, since there are two H2s. So now, all we have to do is subtract the reactants minus the product. So this ends up equaling negative 559, which is exothermic. It is losing energy. So overall, the delta H, or enthalpy of this reaction, is negative 559 kilojoules.